The hour of 3 p.m. having arrived, I would like to open the engineering committee meeting for the Vallecitos Water District. And let's call to order. Do we need to do that formally?
Yep. I don't know. Do we normally take roll or we're both here?
I guess we just call it to order, and that's what I've done. So moving on to item number 1, High Point Pipeline.
Yeah, so we actually have 3 items today. It sounds like we have about a time limit of going till 4:15. So we'll be mindful of the time. We have the 3 items are the High Point Pipeline Condition Assessment, District Solar Update, and a septage hauling update. And unless the committee has any other preference, we'll just take them in that order. Is that okay?
That'd be fine.
Okay, so we'll go with the High Point Pipeline Assessment. And James, are you taking it or am I kicking it right to Susan?
No, you can kick it right to Susan. Susan's going to give you a presentation on the actual findings of the High Point Pipeline Assessment Project.
All right, you're going to hear from our Asset Management Supervisor, Susan Bowman. Go ahead, Susan.
Thank you, General Manager and Directors. I'm going to be presenting to you these results, and included within this is a 5-minute video about the technology that was used. And then we'll get on with the giving you the results from that technology assessment. So let me share my slide here.
And while that's coming up, you'll all remember that this is the project that was going to be developed and just kind of went static and didn't move forward. And it's been out there for over a dozen years, I think. And recently a developer has approached us to see if we'd be willing to take over the infrastructure. So go ahead, Susan.
Yes, that's exactly right. Okay, and this is a map of the project area off of Mesa Rock Road and I-15 and Mesa Rock Road, the Woodland Heights Glen area. It's about a mile long of 12-inch ductile iron pipe, and then we have about a little bit less than a mile long of 8-inch ductile pipe up to the existing Palos Vista tank here at the end of the 12-inch pipe that was installed. So that's the project area that we're discussing today. And yes, on the background on this project, so this was originally called High Point Country Manor, developed or initiated in the mid-2000s. But then with the onset of the Great Recession, 2007, the project was halted. So, but prior to that halting of the project, the developer had put in and around 2007, they had constructed these water and sewer facilities. However, they were never accepted by Vallecitos. There were some final actions that needed to be taken in order for it to be accepted into operation, and that was never done. So the project and the water and wastewater facilities were abandoned. So we're going on about 13 years now that those have not been in use. So in around 2016, new developers came in and wanted to begin developing the project, the High Point area project. So we began working with that developer to see what conditions were needed in order to accept those 13-year-old facilities into the Vallecitos system. And critical to that was a condition assessment, determining exactly what state those pipelines were in and if they could be brought into service. So as we say, we have 2 diameters of pipe up there. They're both made of ductile iron. There's a 12-inch ductile iron. The area that we assessed was on the Woodland Heights Glen Road. And it was, the technology that we've used is called a Pika sea snake. That's what we're gonna show you in the video, what that technology is. And we assessed approximately 2,000 feet of pipeline. So the total pipeline for 12-inch, like I said, is about 5,100. So we did just under half of the pipeline. It was also potholed in addition to the Pika sea snake to see where possible degradation of the polyethylene encasement of the ductile iron existed, etc. And then we did one section of 8-inch ductile that's feeding the side cul-de-sacs that are part of this project. And that was approximately 700 or so linear feet that we did. And as I mentioned, there was 4,200 feet contained within this development. So we did, what is that? Probably about 25% or so. Again, here's another look at the development area. The highlighted in pink is the sections that we did the sea snake assessment on. Okay, so the Pika Sea Snake tool is it's a new technology that was chosen. It's very good for identifying the remaining wall thickness. That's the critical parameter that we're looking at here to determine if there's been corrosion on that ductile iron pipe. As you are aware, we've seen degradation of ductile iron pipe in our system, leading to quite a few failures. And so it's critical that we understand how much really remaining useful life exists for these pipelines up there that have been sitting for a while. So I am going to run the video. Here we go. Can you hear?
Hi, my name is Chris Embry. I'm a regional manager with Pika, and I was a project manager at the High Point Condition Assessment Site. Pika stands for Pipeline Inspection and Condition Analysis Corporation. We have manufactured and developed several tools to inspect pipe. We have inline tools that inspect the pipe from inside of the pipeline, and we also have external tools that can inspect the pipe from the outside of the pipeline. Several agencies here in Southern California and throughout North America are using our technology currently. This technology can be used on any metallic pipeline, and here in the water industry in potable, raw, recycled, as well as wastewater. We inspected the metallic pipelines at High Point. We're using electromagnetic remote field testing techniques to determine the remaining wall loss, in this instance, ductile iron pipe. Many older pipelines are out of sight and out of mind, but working with a proactive agency like Vallecitos, we're able to inspect before there are failures of pipelines.
My name is John Childs. I'm an inspector for Vallecitos Water District. I was the inspector specifically for the Pika High Point assessment up here at Woodland Heights, Glen. We're standing up here at Palos Vista Tank. We're right below the tank. One of the first things that Vallecitos did was we were responsible for marking out old ductile iron mains that are up here. Been up here, I believe, for almost 12 years. These lines have never been used and inactive. Also, there was 2 potholes that were done, and those locations were at known utility crossings, and we just wanted to get an evaluation and see if there was any sort of corrosion happening at those locations. So once we did mark out our lines, it was decided where we were going to make the entry points and the exit points for the Pika Sea Snake. This is a location where we did it. For Vallecitos was overseeing Cass Arietta, who did the excavation, and to remove the section of pipe so the Pika Sea Snake instrument could be inserted. The day of the assessments, we pretty much stood back and just kind of let them do their magic. Vallecitos, myself. I was impressed with Pika's accuracy and the fact that they had come back with 2 different locations after their initial assessment. They had said that possibly could be some major corrosion. Wanted us to excavate on those locations. When we did, we actually found significant corrosion, wall loss. One of them, when we were digging around on it, actually sprung a small leak right where they had said it was. I was completely blown away by how accurate it was. Not only did they give me a linear footage of exactly where it was at, but they actually gave me the clock phase. One was at 10 o'clock and one was at 10:30 on the pipe. And lo and behold, both of them were precisely at those locations. If this had been in service, this would have been quite a catastrophic main break.
After the inspection, we provide a color-coded map of the pipe to show areas of stress, corrosion, through holes, etc. We provide that to Vallecitos and engineers to be able to make a further informed decision. The information collected at High Point can allow Vallecitos to make informed decisions on the remaining useful life, predict failures to save money, focusing their resources on areas of the pipe that need to be replaced and prevent outages, service disruptions, and further issues in the pipeline. In general, our inspections cost between 5 and 10% of the capital replacement cost of the pipelines we're inspecting, and we often find that less than 3% of the pipelines that we inspect need to be replaced. Sometimes if there are breaks in certain areas, it can be an easy assumption that those are the areas that are bad. That's not necessarily the case at all. In some cases, other parts of the pipeline further away and in different soil conditions may be in much worse case, and then the resources can be focused to the areas that actually need the repair and replacement. It was a pleasure working with Vallecitos staff as well as Vallecitos inspection department on this successful project.
In my opinion, having seen the results from the Pika Seascape tool with the accuracy of where they had said, hey, there's a problem, and physically seeing that problem has me impressed. And I do believe that this tool would be a great asset or help the district in assessing other areas of Vallecitos Water District. This has been a success for Vallecitos in that we get to actually assess the assessment. So I see a potential for this Pika technology benefiting both Vallecitos District and its customers, and the fact that we could possibly assess and know of a potential line failure premature and be able to address it. District inspection staff, while we were out here, but this being the first time, we started a rough draft of some standard operating procedures that we would want to follow and use for anytime we use Pika or this type of technology in the future.
Okay, so you may have recognized that that was one of our video productions for the work we do. So kudos to our public information team on that. But I think it gives you a good overview of what the tool was that we used for this assessment.
And Susan, if I may cut in real quick, I just want to
Yes.
point out that
Oops.
this video was shot back in December, so well before COVID. So if anyone says, why weren't people wearing masks and practicing social distance, this happened quite a while ago.
Yes, that's right. It was in, I think, early January, February. Well, actually, it was, yeah, January. Okay, so the results from this assessment, which is, of course, critical to accepting these pipelines. So what you see here are the corrosion findings on the 12-inch ductile iron. These are photos that were taken actually by the corrosion engineer who was also brought in on this project to assess what the situation was. And you can see there's quite a bit of corrosion and pitting on this 12-inch pipeline. And as was mentioned in the video, they even had some leaks that had been uncovered as we were doing the assessment. So the remaining wall thickness that was identified on this 12-inch pipeline is indicated here on this map. It may be a little hard to see, but basically where it's red, that's a remaining wall thickness under 50%. So that means in these 13 years, that pipe has lost well over 50% of its wall thickness. In some cases, as little as 12% remains at this site here, site 65, down to 12% remaining wall thickness. And then the yellow boxes are between 50 and 70%. Acceptable wall thickness at the pressures for this pipeline is above 70%. For the 8-inch, we actually found with minimal corrosion, I should say. The pipes were in pretty good shape. The polyethylene wrap was in good shape for the areas that were inspected. And you can see here, this writing in this upper right photo is actually the original markings that were put onto the pipe when it was installed. And this shows the remaining wall thickness for the area of the 8-inch pipe, 70 and 80%, and nothing that's in the red under 50%. So what are those were the results. And so the recommendations that were put forth by the engineering company that was assisting with this, IEC, and based on the findings as well, is that the 12-inch pipeline has showed significant deterioration and replacement is recommended. For the 8-inch pipe, including the pipeline that hadn't yet been inspected, based on the area that was inspected, it seems to be in a like new condition, but inspection of the remaining pipe is recommended. Okay, I'm going to stop sharing. There we go.
And if I could add something, so the developer working through Rob's group has already requested, what is the district staff opinion, and we've let him know initially that we're going to take this to committee and possibly to the board. But however, right now, based on the recommendation of the report and based on what we've seen, is further review and basically assessment of the 8-inch to ensure that the rest of it is in like new condition. And as far as we know, replace all the 12-inch, because at this point, as you saw from that graphic that Susan showed, it's almost all bad. There's some, and the reasons we don't know. So we've been asked that already. We don't know why the 12-inch is bad and the 8-inch is good. It's just what we're finding in the results.
And I think one of the value of this, the reason we're presenting it is not just to look at the condition of the high point pipelines, but we wanted the committee to better understand the technology that we may use to assess our own pipelines.
Mm-hmm.
So we were very interested in this kind of experiment to see how well the electromagnetic induction results correlated with actual field investigation. And you heard John Child say he was really impressed at how well it really identified and located actual known problems. So we think there's a lot of value to the tool, but unfortunately in this case, unfortunately for the developer, probably fortunate for us, the 12-inch line does not appear to be in very good shape.
Question.
Yes, sir.
How many lineal feet of 12-inch pipe do we have? I can't recall that. I mean, I remember the graphic, but I don't recall the numbers.
5,001. Go ahead.
5,100 linear feet. To about 5,000, a little over 5,000.
We did about 1,000 feet.
2,000.
2,000. Okay. So clearly the developer, if he gets told he has to replace all the 12-inch, he may ask if we'd be interested in doing an inspection of the remaining 60% or whatever of the 12-inch line. And I don't think I'd say no at this point in time, but I don't know if there's a good reason to believe that the results would be significantly different.
Yeah, and that's kind of a risk thing. If he does the inspection of it, the developer's on the hook for the inspection, and then he'll still be on the hook for replacement if the condition is equal to or anywhere close to the existing 12-inch that we evaluated.
And you heard the Pika guy say it costs what, about 5 to 10% of the replacement value of the pipe. So is a developer going to be willing to throw another 10% of the value of replacing the pipe in the hopes that it has results that are significantly different than what the first inspection showed?
Well, the reason I ask is, that's based on the number I used. That's $1 million worth of reduction or redo on that 5,000 lineal feet. So, spending 100,000, 150 at least would satisfy me as a developer that really it's all bad. But I'm puzzled. I mean, we continually have this problem with ductile iron pipe, and we've had all over different soil conditions, different construction situations where they've nicked the wrap and everything. But here on the same project, the 8-inch pipe is like new and the 12-inch pipe is 50% gone. I mean, that just makes no sense to me. And is there an alternative to ductile iron pipe that we have used or have been recommended or whatever?
Yes. So our current standards do not allow ductile iron pipe. We changed those standards. I Rob, you may know this better, like 2016, maybe even before that, 2015. So we are no longer a ductile iron pipe district for new. So all the new pipes that are going in are usually PVC or steel. We use ductile iron still allowed in specific circumstances with approval from the district, where PVC or steel may not make sense. So that's currently our state. Now each pipe material has a different issue or a problem. So you're trading one for the other, but at least with PVC, there's no corrosion issue.
Right. And what problem do we have with PVC?
PVC, when it fails, it's catastrophic failure. It doesn't just spring a leak, it blows up basically. So PVC failures usually have a higher cost, but they're less likely to occur.
Okay. Is there any other product that we've looked at that gives us more favorable outcomes?
Well, steel is a great material, and steel usually has a slower leak unless it gets real bad. But the problem with steel is the smaller diameter pipes you go, you can't ensure that it's coated on the inside because of the welding. So, and every weld or every joint is a failure point in steel, basically. So we use the steel for larger diameters where we could actually ensure through our inspection methods, whether it's CCTV or actually ideally larger diameter pipe where somebody could actually crawl inside the pipe and actually mud the inside, make sure that there's no exposed steels to the water.
I see.
And probably the pipe material we've had the best experience with is probably asbestos cement.
Yes.
Tons of it in our inventory, performs real well, but you can't use it anymore because of the materials that are used. So we can't, that's not an option going forward, but you know, we can do, we don't have to tear out what's in the field right now, but if you have to repair it, you have to repair it in a different fashion.
And almost all of our repairs are PVC repairs. I mean, we're repairing asbestos with PVC. We're repairing ductile iron with PVC.
We can't do the sleeving in those portions of needed repair?
We can. The sleeving, as like we did with Senexin on Stargaze, is it's not cheap. It's doesn't cost as much as replacing that pipe, but it does cost a pretty penny, and that is something that we could evaluate. Now we've only done it in a little cul-de-sac, and we had mixed reviews on the process of it, but that's something that we could work out with the contractor. But we don't know yet the longevity of that material. It's pretty new and it hasn't been tested, so we kind of experimented. We're planning on going in a few years and CCTV to see if it's really holding up. So at this point, we don't really know.
Yeah, in my opinion, one of the best benefits of Senexin is that it's less disruptive. You're not digging a huge trench. In a case like High Point, there's no traffic. There's nobody out there. So if we were to force the developer to replace that 12-inch with something else, it may be better just to have them rip it out and replace it as opposed to entertaining the uncertainty of a lining project like a Senexin.
And Director Hernandez, you also have to remember that the existing trench is there. So, and there's no high lines and no customers. So if the developer were to dig it up, he's digging in his existing trench. He could save some of those existing materials, reuse them. So it's still not cheap, but it would bring the price down significantly. He's not digging into rock. It's not basically new soil, hard rock that he's digging into. A lot of the materials, if he does it right, he could save and reuse, you know, as far as bedding and base and backfill materials. So definitely reduce the amount of materials he has to haul in and amount of materials he has to haul out, because nothing in the existing trench is native. It's all import material anyway.
Yeah. Okay. Well, that answers my questions.
Yeah, I've got a question. Glenn, maybe what's the plan for communicating with the developer at High Point?
Well, I think one of the things we wanted to hear from the committee is this something that we think we should be bringing in front of the whole board, or can we get enough confidence level here that we should be communicating with the developer directly and just say, hey, it looks like the 12-inch is a no-go. You have to replace it. My guess is that the developer is going to push back if we ask them to replace all the 12-inch, and it may get elevated to the level of the board anyway. So maybe spend a few minutes talking about what your thoughts are on the board's involvement on something like this. Because, I mean, typically we wouldn't bring, if there was a product in the field that failed, say like an inspection, we wouldn't go in front of the board. We would just tell the developer to tear it out, right? And replace it. But that's kind of new construction. This is very different. I mean, it's been in the ground for over a dozen years. A lot of money was invested in it. And the developer's really interested in trying to salvage as much of that investment, even though it's not their initial dollars, right? I think they bought the project from somebody else, but they want to save as much of the investment in the property as they can. So I don't know if either of the committee members have a thought about the board's involvement.
What do you think the developer's expectation is? I mean, is he expecting he may have to replace some of it?
I'll look to James and whoever's, I haven't dealt with the developer directly myself, so.
Yeah.
James, what's your thoughts?
Director Altharp, you're correct. So our initial stance from staff was every single inch of pipe has to be replaced.
This is before the inspection,
This is
right?
before. So then the developer asked us to relook at this or anything else. So then we took that opportunity to talk with the developer and kind of come up with a plan to do an assessment. We've never done an assessment. They were willing to pay for the assessment in the hopes that they don't have to replace the whole pipe. But they're also, we told them that we haven't changed our stance on this. But if the pipe's in good condition, that staff would recommend whatever made sense to the district. The results are kind of in, and the 8-inch looks great. I think it still needs further condition assessment to make sure, but the 8-inch looks like it's in great shape. But obviously you saw from Susan's presentation, the 12-inch, I mean, just even the pictures of it looks deteriorated compared to the 8-inch. Both the pictures in the video, you saw that the rusty pipe that was kind of scaled up was a 12-inch. And of course, the pictures that Susan put in her presentation. So I know for a fact that the developer won't be happy. I think they're hoping that we just say, hey, just do spot repairs and then you're done. But from my comfort level, I don't see that, at least on the 12-inch at all.
What's the percentage, like dollar wise, of the 8-inch?
Rob, do you have an idea? I know there's 4,000 feet of 8-inch and about 5,000 feet of 12-inch, but the 8-inch obviously is cheaper also.
So maybe a
talking about
third.
from like an installation perspective for those.
Yeah.
If I were to take a stab at it, I'd probably say about 35% for the 8-inch, 65% for the 12-inch.
Now, overall installation costs are going to be a little lower because they don't have the import, but they still have to buy the pipe. They still have to dig it, put it in, and bury it. So it's still up there.
Yeah, I mean, I use $200 a lineal foot. You know, that's for a brand new project. So maybe it's a little less than that, but that's still $1 million.
Yeah. Oh, yeah, there's no traffic control. There's a lot of things that are simplified, but yes, and you're digging in all imported fill. You know, that helps out. But maybe it's 150 at the least. You know, it's still expensive.
How many units are up there?
33, I believe.
Yeah.
That's half a house, I guess.
Well, I mean, it's not the only thing. I mean, they're basically, they have to rebuild the pump station. But that hasn't changed. They've known that since day one. This is the only thing that they were hoping to get a better result on.
Yeah. Well, that's $30 a home, and maybe a little bit less, which on that kind of a development, I mean, it's unfortunate, and I'm still baffled by why this pipe in the same ground as the other is deteriorating and the other one is not, but be that as it may. My thinking is, well, if the guy wants to spend the money and test the rest of it and hope for different results, I'd say fine, but that sounds like the insanity explanation, doing the same thing and hoping for different results. But, and if not, then he's going to have to replace the 12-inch pipe.
Hey, James, could either you or Rob maybe walk through the district acceptance procedure? Let's say this was a project that had just been completed and a developer wanted us to accept the improvements. I'm trying to get the linkage between what the board's involvement would be on a traditional project versus what it might be with this kind of delayed acceptance.
Go for it, Rob.
So basically, once we always take a construction agreement before the board. That's always the first step. That allows the developer to initiate construction of infrastructure, pipelines, the pump station, the hydropneumatic tank, all the above. During the installation here, we take a deposit for inspection time because we're going to want to inspect the work here that we're potentially accepting in the future. Once the project work is completed, and they pass the developer of the inspections, then we bring that back before the board for acceptance of the project, and the board accepts the project through a board action.
And this project was no exception, right? We had a construction agreement way back in mid-2000s or whatever.
That's correct. Yeah, so we had a construction agreement. They were just in what we call the punch list stage, where they're just going through the final inspection items. And then at about 2008 is when we stopped hearing from the developer, and they kind of disappeared after a while. And they were about, this close to having project acceptance for all this infrastructure.
So in the time I've been with the district, we've never gone to the board and not accepted the improvements that were constructed as part of development. It's mostly because there's a lot of work behind the scenes, making sure the product is up to the quality that we need to accept it. So this is a bit unique. And Rob and James, I don't know if either of you have had experience where we've actually gone to the board and recommended not accepting any of the improvements, whether it was 13 years old or 1 year old.
Not for me, not here, or even not at OTI either. So
Yeah, so this is kind of uncharted territory for us. It may not be a bad idea to go in front of the board and just tell them, hey, here's what we found out, here's what we recommend, and we can develop kind of maybe co-develop with the developer as to what the next steps are. Because if we tell them no, we're not going to accept the 12-inch, is that just for the piece that was inspected, or is that the whole 12-inch?
currently we're staff's thinking the whole 12-inch. I mean, they're welcome to spend another $100 and something thousand to check the other 3,000 feet. But at this point, it doesn't seem to make sense, because it's not like we saw the pipe degradation change along the lineal footage. So, and as far as Director Hernandez's explanation, I don't really know why. I mean, in talking with some of the inspectors that were here that are now retired, but before they retired on the original job, a lot of that 12-inch pipe was out on the site for a long time before they put it in the ground. Could that have something to do with it? I don't really know. It may not.
Well, it's just very odd. Yeah. Well, that's the situation with developers.
Yeah. But if it's the committee's pleasure to take this to the full board, we could basically give a very similar presentation to the full board at the next convenient meeting.
Oh, personally, I mean, I don't mind taking it to the board, but I don't think we're going to come to any different conclusion than we have here today. That, the developer can test the rest of the pipe, see if that's different. If it is, wonderful, we'll make a decision based on that. But if it is the same as what's already been tested, you're going to have to replace the whole 12-inch line of pipe.
The only thing it does is it gives the developer an opportunity to plead their case in front of the board. That's really the main.
Yeah, but I mean, I can't believe, I don't speak what you will, Greg. I mean, I don't know if the board's going to want to take on the responsibility of accepting the 12-inch pipe as it is. I don't care who the developer is.
My guess is it's going to end up in front of the board anyway. If staff tells them you have to rip it all out, they're going to start either formally asking staff to put it on an agenda, or they're going to individually start lobbying the board members
Yeah,
to intervene in some way.
Well, that's okay. Whatever the desire is, we can take it to the board right now and let developer give his best pitch. I don't think it's going to be much different.
Yeah, and maybe that's what we can offer them, say, hey, staff's gonna be recommending denial, but we're gonna do it at a board meeting so that you, the developer, will have an opportunity to have your perspective be known, and then the board can weigh in. But yeah, at this point, I'm with James. The results are so bad. I mean, it wasn't even close on the 12-inch that we couldn't recommend accepting this.
Yeah. Okay. Send it to the board then. We're in
Okay.
agreement with that.
That it for that item then?
Director Elithar? You in
Yeah,
agreement?
I'm sorry. My connection keeps cutting out, so I'm getting about half of the discussion, but I would, from what I thought I heard, just go ahead and take it to the board right off the bat and give them a chance to discuss it with us.
Yeah,
Yeah.
and it'll be with a staff recommendation that we do not accept the 12-inch.
Right.
And if the developer wants to pose something else to the board at that time, then we'll listen to what he has to say.
Okay.
Okay, thank you.
Item
Thank you,
number,
Susan.
thank you, Susan. James, Rob.
Thank you.
Item number 2, district-wide solar.
All right, I think Ryan's going to take that one.
Yeah,
You did.
so I'm muting myself. I'm going to share my screen. You should all see a plan of the Twin Oaks Reservoir site.
Ryan, could you sit a little closer to your mic?
Oh yeah, sorry. Let me know if you can't hear me. Can you see my screen?
Yes.
Okay. I'm going to start at Twin Oaks Reservoir, give an update on district-wide solar. I don't have a video to share, but I do have a teaser that one is in production. We actually have Alicia out there today filming, so coming soon to a theater near you will be another production there. The Twin Oaks Reservoir project kickoff happened on July 6th. The tank number 1 was mobilized first with racking install completed. Concrete ballast placements are occurring this week, and panel installs will begin on top of the racking as early as next week on reservoir number 1. Reservoir number 2, racking install is ongoing currently. Concrete placements and panel installs are scheduled in the 3-week look ahead. All said, including trenching and undergrounding of conduit and conductors, everything should come to a completion around mid-August, mid to late August is what we're anticipating. There will be a electrical isolation and tie over to the switchgear improvements at the very end of this process, where the reservoirs will be essentially offline from SDG&E for about better part of a week, maybe 3-4 days. So we're coordinating that with operations currently and scheduling accordingly. Switching gears now, I'm going to share a different screen.
Ryan, before you do, which is 1 and 2? Thanks. I can't read if there is an item.
1 is the furthest west here, the smaller of the 2, and 2
All right.
is the eastern tank there.
Thank you.
Let's see. Okay, switching gears to lift station number 1. Lift station number 1 is a little bit delayed due to the fact that we had some redesign in the panels being west facing instead of south facing. We also laid out the array in such a way that it would give us the most clearance from the back edge of pavement. As part of the lift station 1 there, we have about 60 feet from the edge of pavement to the first solar panel. This project is actually being submitted currently for the City of San Marcos site development permit. We met this morning with the city to get that over to them this week. Once the city finalizes the permit process, it could take anywhere between Well, we were told 3 to 4 months, but we've been working with them in good faith, and we have hopes that they're going to kind of expedite the permit process to be faster than 3 months. If everything works out good, timing wise, they will demobilize from the reservoir site and go straight to lift station 1. If there's a little bit of overlap due to the city permit, they'll demobilize and they'll actually have to come back out here again a second time to finish lift station 1. All that being said, we expect approvals as of today by mid-October for a start in mid-October. That would put a completion in December, right at the end of the year. And production and startup with SDG&E will happen in January of 2020. And that's a conservative estimate. It could be faster than that, and we're hopeful that it will be. But as of today, that's how the schedule looks for lift station 1. And that's a quick update for you. I don't have much else besides that, but if anyone has any questions, I'll be sure to take those now.
Hey, Ryan, it's Glenn. Real quick, if the contractor did have to demobilize and remobilize, is that all on him
Oh, yes.
financially? Okay, just to clarify that.
It's to their convenience. And honestly, we've been pushing them along to submit the site development permit for a long time now. And it's really kind of been on their plate for a while. It just, for whatever reason, it hasn't gotten in. So I'm trying to do our best to usher it along. But yeah, everything is totally on the solar provider.
Ryan, it's James. Just another point of clarification. So when we finally go to live production and start receiving the PPA rate and benefit, it'd be both sites at the same time. So January for both sites, even though Twin Oaks is going to be just kind of waiting.
That's correct. It has to be both sites.
Yeah.
All right, any questions? Hearing none, moving on to item number 3.
All right, and that's the septage hauling update, and I think Rob's going to take that one for us.
Yes, sir. I'll go ahead and take this one here. Just had a quick update before the board, or sorry, for the committee here. And let me see if I can make my screen share. All right, how does that look? You can see the figure there?
Yes.
Okay. There's not a whole lot that's actually happened since the last engineering equipment committee meeting where we discussed this. And I think that was, what was that, about the late February or early March timeframe, I think it was, when we last brought this. It actually took Encina's attorney, Procopio, a long time to get back to us. We had some questions about jurisdiction, and if we did a project like this, you know, where could we serve? Could we serve just our agency? Could we serve other agencies? We finally got some answers on that, and that's generally what I'm wanting to present today. After talking with the attorneys, Encina's and Vallecitos' attorneys, well, it's not surprising. Encina's attorneys basically stated that serving outside of Encina's service area would be problematic at this point. We'd probably need to redo the agreement, the revised basic agreement, if we were to try to propose something like that, where Encina is trying to take or trying to process sludge that would be generated outside of their service area. We asked a question about, could we expand outside Vallecitos' service area if we were just going to take the lead on this? And it sounds like that's plausible. We could probably reach out to the other Encina agencies and with the proper agreements and also with some LAFCO approval, we could probably expand some type of septic operation where we do accept septic that's generated in those agencies' service areas. The good news on that there was it allows us to collect additional septage flows here, which helps the costing on this. That would get us to about 30,000 gallons per day if we could achieve basically all of Encina's jurisdictional area. The bad news is, even with that, with all the costs involved here, we're probably looking at a total loaded cost of about 15 to 20 cents a gallon. That would be Vallecitos' cost to treat that septic waste. A lot of different components go into that cost here. Obviously, the capital cost for the receiving station, and then there's other costs that would be involved in the operation and maintenance. You'd have supervision, conveyance, and then treatment and capacity concerns also that kind of add on to that cost. Unfortunately, it looks like the market only supports about a 13 cent per gallon charge on this. Anything really higher than that there, it's very likely that a lot of the collectors will probably continue to just truck their septic waste south to San Diego. So that's what we anticipate the final TM stating. That final TM will probably be done and in our hands, I would say, next week. So that's the quick update on that. I did have a side note here. We had a little twist. We had a company called Cedron Technologies contact us last week. They are actually, they're a small company that's actually looking to site. It looks like they have like a package receiving, like a septic receiving station. They're looking to site something in the North County area. So they contacted us because they've heard that we were studying this as well. And you know, they didn't want to compete with us. They didn't want to try to double dip on us here. So they were just trying to see where we stood, if there's any options potentially for, you know, working with the district, or if there's other options available. It looks like what their process is they have a package system that basically processes septic waste to a Class A biosolids. And then the water here, which is a lot cleaner, gets a lot of the solids out of it there, that would drain right back into a typical wastewater collection system. So they've offered a few options on here, and one of them was potentially partnering with Vallecitos on such a station. If that were to happen, that may or may not affect some of our costs involved here, such as our treatment capacity, for instance, or our capital cost. But that would be an option that we could possibly discuss with them. Other options would be we have them just talk directly with Encina to see if Encina was interested in partnering with them on something like this. A third option would just be we get out of their way and we let them kind of run with this type of concept and see if they can potentially make a profit on the septic collection. So those are kind of my updates on here. And of course, you know, obviously the committee members there have any input there on the technical memo or on the potential partnering with Cedron. Love to hear it.
Question, Rob, what's the name of the company?
Cedron Technologies, SEDRON.
And I mean, they'd be creating the same Class A biosolids that Encina is creating?
Yeah, so basically what they're doing is they would basically be taking septic waste, just like kind of like downtown San Diego is doing right now, but they have a package process apparently that can dewater it and create a biosolids, which they could potentially advertise there as a fertilizer. It does nitrogen and phosphorus removals as well. So it's kind of the same concept that we've been looking at, and kind of the same concept that Encina has been looking at.
Yeah, the big difference is it'd be more of a public-private partnership with them as one of the options, and the waste stream they'd be putting into our sewer wouldn't have nearly the solids loading because they're basically taking a lot of that out. And I kind of looked at their stuff. It's kind of like a filter press with a dryer. So it's like a mini solids process that they're basically taking a lot of the water out and caking it in that. I think they use that as the raw material to produce other things is what happens.
Yeah,
So
no,
Rob, go ahead.
well, I've been working with Encina on their Class A fertilizer, trying to see what the market will bear and all that. And it's a lot tougher than I had anticipated. I thought this stuff would fly off the shelf, but it's a tough row to hoe. Would the company be interested in just doing a ground lease and let us clip coupons?
That's a possibility here. We can certainly discuss with them. Mhm.
Yeah,
The big thing to take away from the draft study, and then once we get it, we'll share it. Obviously, is if we go alone with the factors involved, we're priced out. We're priced out. I think Rob said 13 cents is about the top of the market. What we're shooting for, and we're 15 to 20 depending on assumptions. So even at our lower end assumptions, we're still 15 cents. So to go alone financially doesn't seem viable, but whether it's partnered or something else with another company, that basically would cut out risk and cost in some format.
right. Well, I would like to see your cost estimate breakdown. When we went to Chicago, I did survey a couple of the plants, if you will, that accept this. And I thought it was pretty reasonable, but let me check your numbers and see. But again, if this company is interested in a private-public partnership or just a lease area and we just collect coupons, that may be the best to go for. But I'll have to wait for your analysis. And then the last item, Rob, would you go back to the slide you had with the truck circulation?
Yeah. Mhm.
The one slide, the one truck that's in the middle of the landscaping, was that a drunk driver? What?
It'd be a new exit
Yeah,
that we'd have to build.
Yeah, it must be like a little sleeping area perhaps there for when they get tired.
yeah. Well, it looks like it's a similar truck, and it just decided to land in the parking in the landscaping.
No, it's for a new exit. So basically, they just overlaid it on the Google Earth map, this aerial view, and then this is what the radius would look like for them to get back out into the street.
Right, but I understand the way I'm looking at it. They enter on the top side, do the removal, come out, and then they exit out of the same driveway. Is that not what is happening?
Yes, except we'd have to make it wider for them to be able to pass each other.
Okay, well then this graphic of the truck and the landscaping, it just somebody didn't pull it off of the map.
Well, yeah, so there was actually a different alternatives that we looked at for entry and exit. We did run these alternatives by our operations personnel. This is the one that our operations actually prefers, but we did have other options such as coming in from the west side as well underneath and then kind of doing a roundabout again. And then of course, we had options about, okay, you come in from one side and then you exit on the other.
Yeah, and they didn't like this third option?
Well,
No, this was going to get too much into the site, and then operations had concerns about how to manage these trucks and also get our equipment in and out of the site when we have to do maintenance on the lift
go
station.
ahead and point out the Vactron the Vector dumping station that we utilize on a daily basis.
Yeah, that's a good point there, James. So our receiving station, this is something that our operators use 3 to 4 days a week, actually. Can you see my cursor here?
Yeah, I see where it's at.
Yeah, they utilize this several times during the week there to dump, Vector waste downstream of the lift station that goes down the land outfall. So that would potentially be impacted by this southern entrance area. That is one of the reasons why operations preferred this. I call it the northern entrance, even though I think it's more east than north.
Yeah.
And just to clarify, you can see from here, it's Woodward and Kern doing the study, so it's very similar to the EWA study that you've already seen, Director Hernandez.
Yep.
Including a lot of the assumptions are very similar also. But then also Woodward and Kern was very sensitive to the timing, because if we stop them in the middle of the day, that adds a lot of cost to them. That would, there's a certain amount of dump time and circulation time that the haulers expect to get through the area, which allows us to charge more if we get them in through. Because obviously if they had a waiting line and they were stalled, that would cost them money. And also having trucks queued up in San Marcos Boulevard was not really an option.
No, I understand that for sure. All right. Well, I would like to see the cost breakdown, but I think you've pretty well covered it.
So we'll go ahead and share the draft study with the general manager Prum to hand out to board members once we get them.
Okay.
Okay. That's all we had.
Other business at all?
Well, I guess maybe just solicit input from the two directors in terms of items for the next engineering committee. At that point in time, we'll probably be ready to give a development update and maybe a CIP update.
Yeah,
Are there any other projects you'd like us to bring in front of the committee?
You had a couple of months back an inquiry from a battery company. Have you heard anything more from them?
No, they've gone radio silent. I think they were just kind of testing the waters around. I responded to them, told them we'd be interested.
Yeah.
Told them we have some competing needs, but we're still interested, and never heard back from them.
Okay. All right. Beyond that, I don't know that I have any additional items to add.
Okay, Director Elithar?
No, just the project updates with developer and capital projects.
Okay. All right. I think that's all we had then.
Well, very good. Thank you all very much, and we'll close the committee meeting.
All right. Thank you all.
Thank you.
Thank
Bye.
you.